Now we're going to look at the advantage of also doing an interval, a confidence interval. And a lot of times in statistics, confidence intervals and hypothesis tests can help support each other, especially when you're doing a two-sided, okay, when you're doing a two-sided hypothesis test, that actually equates to a confidence interval. Okay, can anyone tell me how a two-sided hypothesis test is very similar to a confidence interval? Okay, but aren't they related, right? Like the confidence interval, you've got a certain value and you're allowed to go below and above it, right? So you are allowed values on both sides. So that's how it's related to a confidence interval. A two-sided hypothesis test, you're getting probabilities on either end, on both ends. So for two-sided hypothesis tests, a confidence interval can be a good support to prove even more whatever conclusion you make. So we're just going to look at a 95% confidence interval for our mean volume of soda. So the problem we just did, we're going to take that sample mean, 12.017, that sample standard deviation of 0.0391, and n equals 9. We're going to take that data and write a confidence interval, a 95% t interval for the true mean volume of soda. So in other words, based on our sample giving us this amount of volume in that average amount in those cans, what would be the expected volumes that this machine would be producing right now? Okay, so our formula, we're not going to go through all the 4 steps. All we're going to do is the calculations. So we have x bar plus and minus t times s over the square root of n. And no, you shouldn't have forgotten these formulas, okay? All right, so our sample mean was 12.017 plus and minus. Now, we need to find t, the value of t for a 95% confidence interval. Can you look in the back of your book at your t chart? Or you can do inverse t, 0.975 at 8 degrees of freedom. So either way, I'm going to do inverse t, 0.975 with 8 degrees of freedom. And that's going to give me that t should be 2.306. Okay. So that's our t, 2.306, and then s was 0.0391, and divide by the square root of 9, or 3. So I'm going to calculate this part here. What's this part of the confidence interval called? This entire thing? Very good. This whole thing is called the margin of error. And what's just this part called? The s over the square root of n. I'm going to make you look that up. I'm not. If you want to know it, I mean, you'll have to look it up. So. Chapters 19 and 23 on confidence intervals. Or you've probably got formula pages in the back of your book. The critical value is the t. The t is, or the z is the critical value. What? So 2.306 is called the critical value. What is that called? While you're looking for that, I am going to do the calculation. I'm just going to multiply and divide by these. And that margin of error is 0.03 is what I get. So I'm just going to add and subtract. I'm going to make this into 12.02 plus and minus 0.03, which makes my confidence interval, let's see, 12.02 minus 0.05, which is 11.97, and 12.02 plus 0.05 is 12.07.
Is it the standard error of the statistic?
Yes, it is. This is called the standard error of the statistic. And standard error is the same as what? It's same as the standard deviation, only it's using sample values. I know that that's been said at least 4 times in class, I'm sure, and it's supposed to be in your reading. So that is the standard error. It's the same as the standard deviation, S over the square root of n. Isn't that how we calculate the standard deviation when we do the t? The bottom, S over the square root of n, that's called the standard deviation. Okay? It's basically, standard error is just the standard deviation using sample values. And all this stuff is important because you have to know your vocabulary and what it means. All right, so this, I would interpret this interval, you would say I am 95% confident. Thank you. I am 95% confident that the true mean volume of soda, true mean volume in each can of soda is between 11.97 ounces and 12.07 ounces. So that's how you interpret the confidence interval, but we haven't answered the question yet. Based on this interval, should you adjust the machine? Now, some of you are making this stuff way, way too hard to make decisions. It's not meant to be that hard. This is a range of possible values that the machine is filling the cans. What is the desired value that you want to fill the cans?
12.
Is 12 in this interval?
Yes.
Do you need to adjust the machine? No, because your interval captures the mean that you are looking for. So since 12 ounces is in our interval, I'm going to write this over here, do not need to adjust the machine. So we do not need to adjust the machine because the value that we were going for is in our interval. All right, so in many cases we can use confidence intervals instead of a hypothesis test and arrive at the same conclusion, but this may not always be the case, and we already talked about this at the beginning. Confidence intervals are always two-sided, always. That's why it's got plus and minus. I'm allowed to go above and below. I'm giving myself a range of values above and below. So tests can be one-sided, less than tests, greater than tests, or just one-sided. In this case, you have to adjust the significance level appropriate. So for example, using a 90% confidence interval for a 5% one-sided test. Okay, you have to increase or decrease the confidence level if it's a one-sided test. With proportions, the standard deviation formulas are slightly different for intervals and tests. That's the only other thing. And basically the only difference is it uses true values for tests and sample values for confidence intervals. Confidence intervals in general always use sample values. Hypothesis tests use real values, true values, hypothesized values whenever possible. Okay, overall, and here's important. What's the difference between a hypothesis test and a confidence interval? And Alex, what you talked about, you said something earlier about like being on the outside and on the inside. That's kind of what this relates to. So a hypothesis test answers this question. Am I surprised by the observed data? Does the sample value surprise me? And how surprised am I by it? In other words, how different is my sample data from what I want it to be? So the answer is based on a p-value. The smaller the p-value, the more surprising the data. So the more surprised you are, the more chance it's not because of randomization or sampling variability. Okay, confidence intervals answer the question, what values of the population would not surprise me? What's not surprising? These values, I would not be surprised if all 9 cans that I sampled were in between here and here. That wouldn't surprise me. Confidence interval is not surprising. A hypothesis test says, how surprised am I by my results? Okay. The answer for a confidence interval is a range of values for a population parameter. These are approximately the values of the null hypothesis that would not be rejected by the sample. The confidence interval values are the ones where you would fail to reject the null. If it landed in here, you would fail to reject the null. All right, so you've got homework. The homework is on, the pages are wrong again. Somehow I got all these pages wrong in this group. So number 9 is actually on page 500, and these problems are on page 554. Probably not quite, probably a little after, but it's the same section that those problems are on. So we're going to have one more day of notes and review, but this is really just a review problem that we're going to do next time. And you've got your review assignment. We'll do an AP question in class next time too, and then you'll have your test on Friday. In class today we are going to do a worksheet on type 1 and type 2 errors, go over it, and then you'll still have a little time to do your homework. So